All right, so now we'll move on to the final part of this lesson, to finding the mean and variance of a Poisson distribution. Okay, so they say it can be shown that if the random variable capital X has a Poisson distribution with parameter lambda, then the mean and variance of X are both equal to lambda. Okay, so basically we are now discussing about the mean and variance of the Poisson distribution. So they say the mean Ex is lambda and the variance X is or the sigma square is also lambda. Okay, so basically this proof is not given to you. Okay, so you are directly allowed to use this that the both mean and variance are both equal to lambda, which means mean and variance are equal to each other. Okay, so the proof of this is not given to you. You are directly allowed to use this. Okay, so the proof is beyond the scope of the book. Okay, but anyway, the most important property, so one of the most important properties of Poisson distribution is what? The mean is equal to the variance. That's a very important property. Okay, sometimes I mean things that you will be tested in the exam. Okay, the presence or absence of this property can be a useful indicator of whether or not a Poisson distribution is a suitable model for a particular situation. This is something you can be tested in the exam. So if you are supposed to find the mean and variance, and they might ask you, is the Poisson distribution suitable? So one way of answering the question is when you check the mean value and the variance value, if they are, I mean, they can be close to each other. Like, they can be quite close. Okay. So if they are quite close to each other, then we say the Poisson distribution can be suitable. Okay. So here basically I've just given you some formulas reminding you these are stuff you've learned in S1, right? So to find the variance and the mean, variance and the mean. So these are formulas with you learned in S1. Okay, so this is just a reminder. Okay, so basically if you have a data set, this is how you calculate the variance, this is how we calculate the expected the mean. And here if you have a data set with a group with frequencies, this is how you calculate the variance, this is how you calculate the mean. Okay, so these are formulas you learn in S1. Okay, so you should be able to use these formulas in an example and see whether the Poisson distribution is suitable. Okay, so let's go for an example. Okay, so let's move on to exercise 2, question number 1. They say a student is investigating the number of cherries in a fruitcake. A random sample of 100 fruitcakes is taken and the results are summarized as sigma x is 143, sigma x square is 347. Calculate the mean and variance of the data. Okay, so basically they've given you these two values. So how do you calculate the mean? Sigma x over n, right? Sigma x over n is 100, variance sigma x square over n minus sigma x over n whole thing square. So substitute the value sigma x square is given to you 347, n is 100, sigma x is 143, n is 100. So matter of typing in the cal. And you can see I get my variance as 1.4251 and I get the mean as 1.43, right? Can you see? Okay, so part B, so part A is done. Okay, so moving on to part B, they say explain why the results in part A suggest that a Poisson distribution may be a suitable model for the number of cherries in a fruitcake. So guys, why is a Poisson distribution suitable? We commented on this before, right? So when you calculate the mean and the variance, if the values are quite close, right, then we know that the Poisson distribution is suitable. So here mean is almost approximately equal to the variance. So Poisson distribution may be a suitable model. Okay, because you can see they are all very close, 1.43, 1.4251. Right, so variance is a little bit different. I mean the figures here, but if you correct it to 2dp, it's 1.43. So they're really close. Okay, and so here Poisson distribution may be suitable in this kind of a situation. Okay, so moving on to part C, they say using a suitable value for lambda, estimate the probability that exactly 3 cherries will be found in a randomly selected fruitcake. Okay, so you're supposed to use a suitable value for lambda. Okay, they're asking you to use the suitable value. So basically, we'll go with here 1.43, 1.4251. So both are correct to correct to 2dp. This guy becomes 1.43. So we'll go with lambda 1.43. Okay, and what's our random variable? What are we modeling? The student is investigating the number of cherries in a fruit cake. Right, so here our random variable is capital X is the number of cherries in a fruit cake, and that variable follows a Poisson distribution with mean 1.43. Okay, and what do I need to find? I want to find the probability that there is exactly 3 cherries. the probability that x is exactly equal to 3. So that's equal to e to the power minus lambda, lambda to the power x over x factorial. This is the equation for the Poisson distribution, right? And here simple x value is 3, lambda value is 1.43. Substitute the values into the equation and you can get the answer. All right. So I think this concludes the lesson Poisson distribution. All right. So yeah. So basically, this is the idea. Okay. Basically, if they give you, if they ask you to calculate the mean and variance, and ask you if the Poisson distribution is a suitable model or not, basically, compare the values for the mean and variance. If they are quite close, then we can go with the Poisson distribution. But if not, then we cannot go with the Poisson distribution. Okay. So that's the idea in this lesson, in this particular section.